So guys, in the last video we talked about ionic and metallic bonding. Today we're going to talk about
covalent. So we're left with one thing, and of all this, we've talked about this before. In this case here, covalent bonds, aren't they always between what?
nonmetals and nonmetals. So it's just guys upper right of the periodic table, but also including hydrogen. So that's covalent bonding, and the key thing is the electrons are being shared. So what we're going to do is we're going to draw like some structures. It's all about electrons, all right? So let's do chlorine, all right? So chlorine, if you recall, has 7 valence electrons. Again, let me knock you out for a second. Chlorine right here. Chlorine in column 17, 7 valence electrons. Now notice what Mr. D has just done is he's put 7 dots. They represent the 7 valence electrons. But turns out that chlorine, when it's by itself, is never just Cl. He would connect with another chlorine. Now notice that Mr. Dimitrich is putting X's next to him just to represent the electrons from the second chlorine. Now, what's going on?
So these two atoms, are either of them happy with 7?
No, they need 8. 8's the magic number.
Right?
Yeah.
So if this chlorine comes up to this chlorine and like, hey, give me your electron, what is this chlorine going to say?
So this chlorine, he's not happy. He wants one more. So he'd like to steal the one from the chlorine. So if I want to steal it from you, what do you say?
I don't think so.
Because wait, we're both of the same strength.
Yeah,
Electronegativity, we learned earlier, is how we're fighting for the electron. We're fighting for the electron. And we're fighting. So we're both of the same strength, so we have to share.
Yeah, and this is kind of a last resort, but the reality is that if I can share this, then I'm going to claim ownership. And by the way, we talked about this before, the toddler principle of ownership. So whenever we have a covalent bond, this sharing that goes on in the middle, it's really claimed ownership. So this guy right now, it's kind of like the Venn diagrams we used to do.
Yeah.
So this guy right here, this chlorine, not only does it claim the 7 that it has, but also claims this one as part of its own.
And vice versa for the other guy.
Now the way we represent this overlap where they're sharing electrons is we draw a line.
So a line represents 2 electrons shared between 2 atoms. Write that down. That's actually what we call a single bond, when 2 electrons are shared between 2 atoms in a covalent bond. Now we can have a separate instance, right? What happens if we do a different one? Let's do oxygen.
So let's take a look at oxygen. Oxygen is even farther from being happy because
He's only got 6 because he's in column 16. And we could look at this, right? Here's oxygen, column 16. He's got 6 electrons. He's not happy at all. He's really unhappy. But we can put him next to another oxygen who also has 6. Now, how are we going to make them happy?
So in the reality, don't they both need 2?
Yeah. 2
So here's the thing. Every time I share, and this is kind of a godly principle, right? Every time I share something with you, I'm actually getting something back.
Yeah.
So if this guy shares an electron and this guy shares one in, that creates 2 that are being shared between them. So this guy right here, that creates a bond.
Yep.
Then these 2 can share as well, and that creates another bond. Remember, each bond is just 2 electrons that are being shared.
And now what we have is a double bond. And a double bond, write this down, is 4 electrons or 2 pairs of electrons shared between 2 atoms, represented by those 2 lines. But remember, those 2 lines isn't a line, it's 2 or 4 electrons, depending on which type of a bond you have. And then there's a third one.
I'm going to do nitrogen here, and nitrogen is even worse off.
He's only got 5. Bad boy. Sorry. 5, 15. So he's got 5. He's really unhappy. He needs 3 more. But if you put 2 nitrogens together,
I'm going to do X's just to keep it standard.
Yeah.
So it doesn't really matter where these electrons are, but you can share more than 1 or 2. You can actually
also
share.
do the circle thing. So sometimes what I do is I do this, and I grab, he wants 3 more. And then this bad boy wants 3 more too. And then in the intersection, how many electrons are there?
Now there's 3 that are being shared
Yeah, because
between
it's 1, 2, 3, 4, 5, 6. 6 electrons is 3 pairs, and this is what we call a triple bond. There is no such thing as a quadruple bond.
There isn't. And the other thing is that you need to be aware of here is that whenever you have a single bonds are predominantly weaker than double bonds, predominantly weaker than triple bonds. And part of that reason is because of how long they are. A single bond, it's kind of like this. If this COVID restrictions be damned, right? This right here is me showing a single bond, right?
Yeah.
So I have the freedom to stretch out as much as I want. But let's say we do a double bond, and now we're locked in, and now we don't have the ability to get around or go anywhere else.
And then triples is
Triple, yeah, we don't even want to talk
arms.
through that. Or locking legs or whatever. So we just get tighter and tighter every time that we draw another.
So on this one, we notice that we've got Cl, and we could write this, when we write this as a formula, it's Cl2, this is O2, and this is N2. So it turns out that there are some covalent compounds, whenever you see them by themselves, they are always by themselves. And the way to remember this is say this, Mr. Brinkelhoff. Can you say that, Mr.?
Brinkhoff.
Mr. Brinkelhoff.
Brinkhoff.
Who? Mr. Brinkelhoff.
Brinchlhoff. All of those, when they're by themselves,
Are we call, what's the word fancy, diatomic.
They always exist. Di means two, atomic means
Two
two
atoms.
atoms. So we're in each one of these, when you write them by themselves,
Br2, I2, N2, Cl2, H2, O2 after. Mr. Brinkelhoff. Now also there's a way to look at this on the periodic table. There's, by the way, 7 Brinkelhoffs. And if you look at the periodic table here, it's NOF, ClBri. Do you notice that looks like a 7? So NOFClBri, and you have the addition of Mr. Hydrogen too. So it's not like there's 6 in that and 1 here, but that's another way to remember it. So if you ever are asked to react with oxygen or react with chlorine, you never write Cl, you write Cl2 or Br2 or whatever it might be.
and even if we didn't understand this, like we probably haven't learned about Brinkelhoff. I mean, when we talk about oxygen, you see it in movies or whatever else, it's always O2.
Yeah.
You never hear someone saying, give me some O.
No,
Or
give me some O2.
O2.
All right, we'll catch you on the next video.
Indeed, see you then.